Hello and welcome. In this screencast, we will use restricted versions of the sine, cosine, and tangent functions to evaluate inverse trigonometric functions. Previously, we saw that the cosine, sine, and tangent functions do not pass the horizontal line test and thus do not have inverses on their entire domains. However, if we restrict each of their domains, then we can consider their inverse functions. Take a few minutes to review our previous work and complete the table below. Now that you took the time to review the restricted domains for the sine, cosine, and tangent functions, check your work in this table. In particular, notice that the range of the inverse cosine function is the closed interval from 0 to pi. That means the outputs of the arc cosine function will always be angles in quadrants 1 and 2. Also notice that the range for the inverse sine and inverse tangent functions is the closed interval from negative pi over 2 to pi over 2. Recall that negative angles signify traversing the unit circle in the clockwise direction. That means negative pi over 2 is here at 0, negative 1. That also means that the outputs of the arc sine and arc tangent functions will always be angles in quadrant 1 and quadrant 4. Specifically, we will represent angles in quadrant 4 from the perspective of traversing the circle clockwise. That means we will represent 11 pi over 6 as negative pi over 6. We'll represent 7 pi over 4 as negative pi over 4. 5 pi over 3 will be represented as negative pi over 3. Now that we've reviewed the restrictions required for the inverse sine, cosine, and tangent functions, let's practice evaluating some inverse trigonometric functions. So we're going to use the special points on the unit circle to determine the exact values of each of the following numerical expressions. So the first one we want to find is the arc sine of the square root of 3 over 2. We know the output of the arc sine is an angle, and that angle has to be between negative pi over 2 and pi over 2. And we see that the angle whose sine function is square root 3 over 2 is pi over 3. Next, we want to find the arc cosine of negative 1/2. The output will be an angle, and with arc cosine, that angle will have to be between 0 and pi. So the angle whose cosine is negative 1/2 and is between 0 and pi is 2 pi over 3. Next, we have the arc sine of negative 1/2. We know the answer will be an angle between negative pi over 2 and pi over 2. And we see on the unit circle that the angle whose sine is negative 1/2 is here. We could say 11 pi over 6, but because of this interval, we're going to think of it as clockwise, so negative pi over 6. All right, next we have the arc tangent of the square root of 3. So again, we're looking for an angle between negative pi over 2 and pi over 2, whose tangent would equal square root of 3. So here we have two options. We could think about the tangent of pi over 6. That would equal 1/2 divided by the square root of 3 over 2. And if we multiply the numerator and denominator by 2, we get 1 over the square root of 3. And that is not what we're looking for. We're looking for an angle whose tangent is the square root of 3, not 1 over the square root of 3. So that's not going to be our answer. which means we can try the other angle in the first quadrant that involves the square root of 3, and that would be the tangent of pi over 3. So when we do the sine divided by the cosine and multiply numerator and denominator by 2, in this case we do get the square root of 3. So that tells us the angle whose tangent is the square root of 3 is pi over 3. All right, let's look at a few more examples. They're going to be a little trickier, but why don't you try these on your own first, and then we'll check. Okay, so next we wanted to find the arctangent of negative pi over 3. Again, the angle will be between negative pi over 2 and positive pi over 2. This time we want the angle whose tangent is negative pi over 3. And so we see, well, we knew that at pi over 3, we would have a positive square root 3 for the tangent. And so if we actually go in the fourth quadrant at 5 pi over 3, we'll have a negative square root 3 for our tangent. But remember, we're going to represent that as a negative angle. We're going to travel clockwise pi over 3. So we're going to say that answer is negative pi over 3. All right, now we have the sine of the arc cosine of negative square root 3 over 2. So we're going to start with our inner function first. We're looking for an angle. This is an arc cosine, so an angle between 0 and pi, whose cosine is negative square root 3 over 2. And we know that that angle, looking at our unit circle, is 5 pi over 6. So now we need to find the sine of 5 pi over 6. And you might be wondering to yourself, wait a minute, I thought for sine we had to restrict ourselves to quadrant 1 and 4. And what I want to remind you of is that it is the arc sine for which we are restricted to quadrants 1 and 4. If we just have the normal original sine function, we can input any angle we want and we'll only get one output value. So we can go ahead and evaluate the sine of 5 pi over 6, which will equal 1/2. All right, so our last one is going to be somewhat similar to that. We have the arc sine of the tangent of 3 pi over 4. And we know 3 pi over 4 is over here in the second quadrant. So again, you might be thinking, wait a minute, I thought with tangent we're restricted to the first and fourth quadrants. And again, that's only with the inverse tangent, the arc tangent, where we have that restriction. So the tangent of 3 pi over 4 is going to be sine over cosine. The sine value at 3 pi over 4 is square root 2 over 2. The cosine is negative square root 2 over 2. So we're just going to get negative 1 there. So we have the arc sine of negative 1. And now that we're dealing with an inverse, this is where we are restricted. We're looking for an angle now between negative pi over 2 and pi over 2, whose sine value would be negative 1. And here at 3 pi over 2, the sine value is negative 1. But again, we're going to represent that as an angle going clockwise. So that will be represented as the angle negative pi over 2.